The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe.
For decades, Pluto was a world of silence, a frozen enigma drifting at the edge of sunlight, forgotten by time and untouched by warmth. It was the lonely outpost of our solar system, a ghostly sphere wrapped in eternal night. When NASA's New Horizons spacecraft swept past it in 2015, humanity held its breath. For the first time, we saw Pluto not as a distant blur, but as a world alive with texture and color, vast glaciers, towering mountains, and an atmosphere that shimmered like silk in the dim glow of the sun. But beneath that beauty lay a mystery that no one could explain. The data didn't add up. Pluto's atmosphere was far colder than it should have been, over 30 degrees colder than every model predicted. It wasn't a minor discrepancy. It was a cosmic anomaly. Something, perhaps even someone, was draining heat from Pluto's skies in ways physics could not justify. For nearly a decade, the question lingered, unanswered. Then came the James Webb Space Telescope, humanity's most powerful eye in the void. And what it found on Pluto would shake the foundations of planetary science and hint at something far stranger than anyone dared imagine. When New Horizons sent back its breathtaking images, scientists expected a lifeless world. Instead, they found landscapes carved from frozen nitrogen, mountains of water ice rising like crystal fortresses, and plains stretching for hundreds of kilometers. But the real surprise wasn't on the ground, it was in the sky. Floating above that frozen wilderness was a thin, bluish haze layered in faint glowing bands. It wasn't supposed to be there. It rose nearly 300 kilometers high, far beyond what any known physics could sustain for such a small, cold world. And stranger still, it was too cold. The atmosphere's temperature defied reason. Even when scientists recalculated, cross-checked and reran their models, the math refused to cooperate. Something invisible was stealing heat. Year after year, the anomaly persisted. No one could explain it, until 2017, when a planetary scientist named Shi Jiang from the University of California, Santa Cruz, proposed an idea so radical that most dismissed it outright. What if Pluto's haze wasn't passive? What if it was active, chemically alive in a way, regulating the planet's temperature like a breathing organism? Jiang theorized that the haze particles, tiny solids suspended high above Pluto, were absorbing ultraviolet light from the sun and re-emitting it not as visible light, but as mid-infrared radiation, heat. But instead of warming the planet, this process radiated energy into space far more efficiently than gases ever could. In short, Pluto's haze might be acting like a colossal thermal shield, cooling the planet from above. The idea was heresy in planetary science. The notion that solid particles could control a planet's climate went against decades of atmospheric understanding. But Jiang made a bold prediction. If his theory was correct, Pluto's haze would emit a specific mid-infrared glow, an emission pattern so faint that only one instrument in existence could ever detect it, the James Webb Space Telescope's mid-infrared instrument. In May 2023, that test finally came. An international team led by Tanguy Bertrand pointed the Webb telescope toward Pluto and its moon Charon. Webb's sensitivity was unlike anything before it, precise enough to separate the faint heat signatures of the two worlds, something no other telescope had managed. The team scanned Pluto in multiple infrared wavelengths, 15, 18, 21, and 25 microns. What they found defied every expectation. Pluto's infrared glow was too strong. The energy coming from above its surface couldn't be explained by frozen nitrogen or methane alone. Something in the atmosphere was radiating extra heat into space. When the scientists subtracted Charon's contribution, what remained was undeniable. The spectral pattern matched Jiang's 6-year-old prediction exactly. Pluto's haze was glowing, radiating infrared energy like a living thing exhaling into the cold. NASA had found the missing heat. The haze wasn't a side effect. It was the cause. That discovery rewrote the rules. For generations, scientists believed that gases dictated planetary climates. Carbon dioxide warming Venus, methane shaping Titan. But on Pluto it was solids, microscopic, tar-like compounds called tholins, that governed everything. These tholins form when ultraviolet light breaks down methane, sparking chemical reactions that produce complex hydrocarbons. As these particles descend, They form layers of haze that radiate heat outward, cooling the planet from above like a self-regulating system. Pluto, it seemed, was not dead at all, but a massive chemical engine, its atmosphere continuously forming, glowing, and collapsing in rhythm with its orbit. And Webb revealed even more. Methane escaping from Pluto was drifting toward Charon, its moon, where sunlight transformed it into reddish organic compounds, the same material painting Charon's poles crimson. In a sense, Pluto was painting its moon with chemistry. But even that wasn't the most extraordinary part. Webb's instruments hinted that this haze-driven cooling wasn't unique to Pluto. It might be happening throughout the solar system, and possibly far beyond. The first suspect was Titan, Saturn's largest moon. Its dense orange haze and methane-rich skies made it a natural comparison. When Webb turned its lens toward Titan's limb, the results were uncanny. The same mid-infrared wavelength seen in Pluto's haze appeared again, only stronger. Titan, too, seemed to be radiating its energy away in organized rhythmic waves, as though its atmosphere were alive, breathing heat into the void. The parallels were impossible to ignore. Scientists began calling Pluto and Titan mirror worlds, two frozen bodies cloaked in haze, governed by chemistry that felt less planetary and more biological. Even Neptune's moon Triton began to whisper similar secrets. Once dismissed as geologically dead, Webb detected faint heat emissions in Triton's nitrogen haze, echoes of the same process. These distant worlds weren't inert after all. They were participating in a shared pattern, bound by an invisible rule that linked light, chemistry, and energy across the solar system. And that was just the beginning. The compounds responsible, those same tholins, were turning out to be far more complex than anyone expected. Under Webb's spectroscopic gaze, their chemical signatures revealed intricate chains of hydrocarbons, containing nitrogen and oxygen, the very building blocks of amino acids, life's most fundamental components. On Earth, similar reactions in our upper atmosphere helped seed the chemistry that led to life itself, which meant Pluto's haze wasn't just cooling the planet, it was cooking chemistry on a planetary scale. Dr. Bertrand called it prebiotic photochemistry, the chemistry before life, happening in real time. But what came next was even stranger. Webb's instruments picked up something rhythmic within the haze's emission pattern. The intervals between each infrared pulse matched Pluto's rotation period almost perfectly. 6.4 Earth days. The haze wasn't just glowing, it was pulsing, synchronized with the planet's daylight cycle. As if it were breathing with Pluto's rotation, the boundary between chemistry, physics, and something more began to dissolve. As Webb's data poured in, researchers extended their analysis beyond our solar system. They found exoplanets orbiting dim red dwarfs, worlds like K2-18b and TOI 700d, displaying faint dips in mid-infrared light identical to Pluto's haze emissions. It was impossible at first to believe. These planets were larger, warmer, and bathed in alien sunlight, yet their atmospheres behaved the same way, radiating energy outward, stabilizing themselves. That balance hinted at something profound. Habitability. Perhaps life didn't begin in oceans or under sunlight. Perhaps it began in the cold, in hazes that protected fragile chemistry from destruction, creating stable, self-regulating systems that could evolve. Maybe Pluto wasn't an outlier. Maybe it was a prototype. When Webb's findings reached NASA headquarters, a series of internal reports were quietly restricted from public access. One, titled Atmospheric Anomalies, Pluto and Triton Comparative Study, mentioned non-thermal infrared emissions inconsistent with radiative equilibrium. In plain terms, Pluto was breaking the rules of thermodynamics. It wasn't just losing heat, it was drawing energy from an unknown source. Further analysis revealed weak electromagnetic pulses, flickering above Pluto's terminator line, the boundary between day and night. They pulsed in a regular rhythm, too ordered to be random. Some scientists speculated auroral activity, others an electrical discharge. But one phrase buried in the report caught attention. Haze particles exhibit properties consistent with conductive microstructures. Conductive, as in capable of carrying current. If true, Pluto's sky wasn't just chemical, it was electrical. The haze might be functioning like a planetary circuit, channeling energy through invisible filaments across its surface. Suddenly, the question changed. It wasn't, why is Pluto so cold? It was, what is it doing with all that energy? Then came the discovery that silenced every room at NASA. When Webb turned its instruments toward Pluto's night side, scientists expected nothing but darkness. This was, after all, the edge of the solar system, an ancient, frozen relic drifting in near-eternal twilight. But what Webb found was light, faint, rhythmic, and impossibly structured. At first, they thought it might be reflected light from Charon, but the geometry didn't fit. The pulses were too regular, too exact. They weren't random reflections. They were signals. The mid-infrared detector recorded oscillations every 247 seconds, identical to a mysterious cosmic pulse Webb had detected months earlier from deep space. The realization was immediate and chilling. The same frequency observed billions of light-years away was now echoing from Pluto's surface. NASA's team ran spectral decomposition on the signal. What they found froze them in disbelief. Each pulse contained tiny amplitude variations. When mapped mathematically, they formed ratios: 1.618, 3.14, 2.718, the golden ratio, pi, Euler's number. The constants of the universe. This wasn't random noise. It was encoded, intelligent. The discovery was instantly classified. Officially, NASA labeled it instrumental interference. The data was sealed and redacted, but not before independent researchers retrieved fragments of the raw signal. When they reprocessed it, the truth deepened. The pulses weren't coming from Pluto's atmosphere at all. They were originating from beneath the surface. Webb's spectrometer detected faint echoes bouncing off something metallic, roughly 12 kilometers below the ice, a perfectly spherical structure spanning nearly 1/3 of Pluto's diameter. Not rock, not ice. Something reflective, constructed. For decades, scientists assumed Pluto was geologically dead. But beneath its frozen crust there was motion, tremors pulsing in sync with the infrared signals. The emission wasn't background radiation. It was a message, a transmission using the universal language of mathematics, physics, and geometry. One researcher described it in a whisper. It's like the planet is trying to speak. NASA denied everything, insisting the readings were artifacts of data interference. Yet behind closed doors, scientists resigned after being asked to sign non-disclosure agreements. One leaked note from an anonymous insider contained only 6 haunting words. Pluto is not what we thought. It's something built. Since then, that faint pulsing has never fully stopped. Sometimes it strengthens, sometimes it fades, as though responding to observation itself. Webb still detects it occasionally, buried deep in cosmic noise, repeating the same mathematical pattern, the same silent code written into the fabric of space and time. And with every pulse, the question grows louder, not what Pluto is, but who or what placed it there. If this story made you wonder what NASA truly knows about the outer solar system, don't look away. Subscribe and stay watching, because the next time the James Webb Space Telescope turns its gaze toward Pluto's frozen heart, the universe might finally answer.